Good morning everyone. Myself Meenakshi, Assistant Professor and HOD, Department of Allied Sciences, R.H. Jalappa Institute of Technology, Durgapur. Today I am going to explain the concept of permutation and combination. So as we all know, permutation is nothing but the number of ways of arranging. Suppose there are n different objects and out of that we have to arrange any r objects in a line. Then the number of arrangements is denoted as NPR or Pn r, and it is given by the formula n factorial divided by n minus r factorial. And suppose we wish to arrange any n different objects in a line, the number of such arrangements is denoted as npn, and it is given by the formula n factorial. Suppose there are n objects. Out of the 10 objects, there are n1 objects are of one type, n2 objects are of second type, etc. and nk objects are of the kth type. Then the number of ways of arranging such objects is given by the formula n factorial divided by n1 factorial, n2 factorial, etc. nk factorial. Now let us solve some examples on this. Suppose there are 6 men and 6 women have to be seated in a row. We have to find out the number of ways they can be seated if any person may sit next to any other person. And second condition is if men and women must occupy alternate seats. Now we know that there are 6 men and 6 women. The 6 men can be arranged in 6 factorial ways and 6 women can be arranged in 6 factorial ways. Totally there are 6 plus 6, 12 people. Without any restriction, the 12 people can be arranged in 12 factorial ways. That is, without any restriction, if any person may sit next to any other person, the number of possible arrangements is equal to 12 factorial ways. Now the second condition is the men and women must occupy the alternate places. So the men and women can occupy the alternate places in 2 ways. The first way is men can occupy odd places and women can occupy the even places. Men can occupy the odd places in 6 factorial ways and women can occupy the even places in 6 factorial ways. Hence by multiplication rule, the men can occupy odd places and the women can occupy the even places in 6 factorial into 6 factorial number of ways. Similarly, the men can occupy even places and women can occupy the odd places. Again, men can occupy even places in 6 factorial ways. Women can occupy odd places in 6 factorial ways. Hence, by product rule, men can occupy even place and women can occupy odd places in 6 factorial into 6 factorial number of ways. Hence, by addition rule, the men and women can occupy odd